Hello. Earlier, I presented you with a problem. The St. Patrick's Parents Council, they wanted to resod our field and put a brick border around it. And I asked you how much it would cost to do this, how much it would cost for us to get a new field. And this is a problem that kind of presented a number of different challenges and enabled you to come up with different strategies to solve it. Now, the first main strategy that I wanted you guys to look at was understanding that our field actually has multiple shapes within it. So if I take a look at Group B here, Group B did a very good job of showing that we have both a circle and a rectangle within this shape. So our field is essentially made of two half circles on either end and a rectangle in the middle. And what some other groups also noticed that when we took a look at the field itself, we also had a relationship between the width of the field here, and this relationship was also equal, or half that width of the field was equal to half of it was to the radius of the semicircle. And so that was understanding one measurement could also lead us into other types of measurements. Now, other groups, when we looked a little further at this problem, is we had to apply the correct formulas. And we had both the area formula, so that'd be the area of grass that we needed, and also the perimeter, which was how many bricks can we put around it. And some groups did a very good job of applying these kind of different formulas. I think Group A here, they did a very good job. So I'm going to go out a bit here. So Group A, they had the perimeter of the field and they calculated, and they just used the curve of the field, which they called A here. I'm just going to highlight it, this curve, and they say it was 67. Then they added it to kind of the length of it, or the 2 times the length of it. Then they also took the area of a circle. That nice formula, A is equal to pi r squared. And then they just kind of combined it with the area of the rectangle. So they had these different formulas, and they correctly calculated both the area of the circle separately and the area of the rectangle separately, and also the perimeter the whole way around. Some other groups, though, made small calculation errors. If I go back to Group B, they made a small error in the order of operations. So Group B, they correctly identified the radius as being kind of half this length, but when they did the calculation, they didn't square the radius first. And squaring is before dividing or multiplying. Remember our bed mass. So as a result, they got a little off in their area. And because they got a little off in the area, the rest of their calculations kind of went all a bit sideways. Other groups, which I found this quite interesting, actually, if I show them here, this group, Group D, they did the perimeter of the whole rectangle, but then they realized their mistake and then subtracted it. So the perimeter is actually just the perimeter of the entire way around, not the perimeter of each shape individually. So they made a mistake, and then they kind of corrected their mistake, which was pretty good. Now, almost all these groups, all of you, did a really good job at identifying the circle and the area, then kind of combining both the area of the rectangle and the area of the circle, and also the perimeter all the way around. And the only thing I'd have to say there where we got a little bit confused was when we tried to convert from meters to feet. And you can see here, especially with this group, right here, the conversion here is not exactly correct. Because with the area, we have meters squared, and that's equal to about 10.75 feet squared. So these guys are a wee bit off on the number, on what they should have got. And that's fine, we'll deal with those conversions. That just is a bit of attention to detail. Now, all of these were well done. All these were of a high level. You worked together. Measurements were a bit different, and this just depended on the strategy you used to measure the field. So with these types of questions, these are called composite shapes. So composite shapes. We have a couple things that we look for when we want to solve these questions. First of all, we want to identify all the regular shapes. So these are the ones like circles, squares, triangles, regular shapes within the object. Within the object. And once we do that, then we can look for the relationships between them. That means that in some cases, if I have a shape like this, well, that's going to be a triangle and a rectangle. And a relationship between them would be, well, this side length here is also equal to the base of my triangle. And so if I know what this is, then I'll know what this is, and that helps me with my calculations. And that's kind of a relationship between these kind of different measurements, or relationships between the shapes. So in our problem earlier today, you guys had to realize that the width of the field was also equal to the diameter of the kind of half circles on either end. Now, another thing we want to kind of identify or look for before when we do these questions is that we correctly use formulas. So we use formulas and we use them correctly. So if we identify that we have a circle, we use the circle formula, so area of a circle, perimeter of a circle, circumference of a circle correctly. And we can use these relationships maybe to identify or find kind of like missing measurements. And the last thing we kind of want to look for is we want to like use and show a strategy to solve it. So there were some groups, in particular, I would say group C here, where their strategy wasn't obvious. We couldn't really see what they were doing. Their numbers ended up being rather close to the answer, but it was kind of hard to follow it. And so like their strategy may not have been obvious. Whereas group A here, their strategies were actually quite clear, and this communication part is actually really, really important. So they identified their strategy, we saw it, and they're kind of combining the shapes, so it's just not really easy to see. And the last one is converting units, and I will draw this very big, because units are always important. Units kind of give us context. Context with any kind of mathematical problem is always very, very important. And these are things I definitely want you to think about each time we have one of these composite problems. So make sure to write this down in your notes, all these different steps. So whenever we solve these problems, we can follow each one of these kind of 5 steps. Thank you.